Hello, friends. This is your host, Rodrigo, and this is another session for the Dapr in Action series. Last time I was choking in front of the camera, and if you watched the recording, I was struggling with my health. And today I'm feeling better, and this is the learning checkpoint part two, where we're going to see some building blocks that we've seen in the past, but I want to show you in a single application how I'm using the bindings building block, service-to-service communication, state management, and I think that's it. We have a lot of things to say today, and let's jump right in. So you might remember last time we talked about the pop-sub building block that allows you to send asynchronous messages between components or applications or microservices. So this is pretty cool since you can develop and build your applications by using an abstraction instead of using, a particular and concrete SDK for a message broker, such as Redis or RabbitMQ or Azure Service Bus or whatnot. Okay, so this is pretty cool because this is an abstraction that allows you to send some asynchronous messages between applications. And let me show you this solution that we have here named Hospital. And we have two projects. This is, I'm using .NET 9 because this is the latest version of .NET at the time of this recording. So let's check this out, okay? So I have this patient's controller that you can see here on the screen. And you can see that I have this HTTP post endpoint that I can use for creating new patients. Let's say that this is an application or microservice for creating or registering patients in this particular hospital. This is a fictitious company, right? So as you can see, the payload is a new patient object, which is this record that we have here on line 44. And this is taking first name and last name. And that's it. I want to, use thing step by step. I don't want to use quite complicated models right now. So first name, last name, and I'm receiving the payload. And here in this particular line, I'm using publish event to this topic. I'm sorry, to this component, and this is the topic name. So the component name, you have to have a component with that name in its metadata that is going to be called or invoked by the Dapr sidecar so it can send a message to the patient's topic, right? So, of course, if we go ahead and navigate to the Dapr folder, remember that is inside your home folder, and then .dapr. Here you can find this particular structure, and inside components, you're going to have the popsub.yaml file, and this is actually the one that is going to be invoked. So we can see in the metadata, you can see this is a YAML file, right? Similar to the ones that we use in Kubernetes. And this is the popsub component. I can identify this by using the name attribute that is inside the metadata attribute. This is, very similar to the ones that we use in Kubernetes since we have API version, kind, metadata, and spec. And as you can see, this is configured for using Redis, particularly my local Redis container that is running on port 6379 here in this computer. And this is because I'm running Docker desktop. And when I initialized Dapr, all the different containers were pulled in this particular machine, and everything is configured when you initialize Dapr, right? So far, so good. So let's test this out, okay? As you can see here, I'm running. Let's stop this and this other as well, since I want to show you the commands for running the sidecar. That's the magic, friends. That's the magic that allows you to use the Dapr sidecar. First, you need to run the sidecar. We have different options for doing that. However, I'm gonna use the Dapr run command since it's very flexible. And of course, this is for local development purposes, right? So Dapr run, and then I pass the app ID, which is the name that I want to set for this microservice or application. In this case, is patients, and then Dapr HTTP port. This is gonna be 55,000. It could be any port you like. And of course, I'm using this one because it works on my machine right now, okay? And the application port is 5500, since after the 2 dashes, you have complete control over the application initialization process. So, of course, we're .NET developers, and we use the .NET CLI for running applications. So you can see that I'm using .NET Run and then passing the URLs flag for specifying the port where this project is going to be running, right? So let's jump right in. Let's execute this. So this is running. The sidecar is executed and alongside my application. So that's the patients microservice, and this is the same for the consultations microservice. Of course, the app ID is different, and the Dapr HTTP port is different as well, and the application port also. So let's execute this, and I know those 2 applications are running right now in my machine, so I can go ahead and navigate to, let's say, Postman, right? Or you can use curl, whatever floats your boat, okay? I'm using Postman here, and you can see that I'm pointing to this endpoint, which is patients, and I'm using post, right? I'm sending this payload, pretty easy stuff. I'm gonna clear the response because I was testing this beforehand. So let's send, let's say, Simon, right? Let's send this. So the patient is created and it's returning a patient ID. Pretty easy stuff. This is just a regular web API. This is returning the ID. This is the patient ID, okay? So I can go ahead and execute the patient's endpoint. So I can see that this is returning all the patients that are registered. I'm using the Entity Framework core and it's in-memory provider, since I don't want to, mess around with connection strings and so on. That's why I'm using the memory provider. So far, so good. So now you can see in this other tab, I have the consultations patients endpoint. So I'm sorry, this other one. Yes, this one, consultations patients. Since, I sent that message to the topic, which is patients. And if we see the code inside the consultations API, we can see that we have this topic attribute. And this is the way, or one way, that you can use with Dapr for asynchronously receiving those messages, right? This is beautiful, since I'm not, I'm not using any kind of SDK for connecting to Redis. I'm just specifying this attribute in this public endpoint, and it's gonna receive the message, which is a patient created. In this case, I repeated this model, which is right here, patient created, GUID ID, daytime created ad, pretty easy stuff. I'm receiving the patient that was created. And actually, that's it. I'm using another different DB context for storing that patient in this other microservice, right? So we have two different data models, one for the consultations API and this other one for the patients API. So if I execute this is going to return the patients inside the consultations microservice. Make sense? Since when you're creating this kind of applications, sometimes it's not a very good idea to use a single shared database. I believe that's possible, and it's maybe you have to have a very good reason for using a shared database. Maybe you're using this, I don't know, legacy technology, very ancient database that you can share between your microservices, and I think that's fine, right? But sometimes, or generally speaking, for microservices, you want to have different data stores. That's why I'm storing the patient's data inside the consultations microservice as well. So far so good. And we have this other endpoint for starting a new consultation, because the first step was registering the patient itself, right? And then you can start a consultation with that patient and a doctor. Let's say that we have this, let me clear the response, and I'm gonna copy this patient ID. Let's go back here and say, I want to start a consultation between Dr. ID number 1 and the patient ID that I created, who is Steven, right? So let's start this consultation, and it's returning this payload. And this is possible since I have the patient ID record itself inside the consultations database, right? And I can go ahead and use this other endpoint, which is consultations, and I'm passing this consultation ID, and let's execute this, and you can see that I'm returning the complete information about that consultation. But in this case, I'm showing you another building block that is the service-to-service communication building block. And this is because you can see here, right? I'm exposing this endpoint, and of course, I'm injecting the Dapr client object since I'm using the .NET SDK. And here, line 60, I'm using invoke method async. So this is the way that we can use in the .NET SDK for Dapr for invoking a method that is exposed in this other microservice, right? So inside the consultations microservice, I'm invoking the patient's microservice, specifically this endpoint, which is patients/patient ID, right? So that's why the first thing I do is retrieving the consultation record itself. Then I'm obtaining the patient ID, and that's why I'm able to send this request to the patient's microservice. And that's why I'm, creating this dynamic object, and because I want to keep things simple, and I'm returning the first name and last name of the patient, right? So pretty easy stuff and powerful things that we can do with the service-to-service invocation building block. So this is actually what's happening here. I'm using, consultations, and I'm communicating to the patient's microservice. And there are some features that the service invocation building block has. And I strongly recommend you go to this service-to-service invocation session that was recorded, and you can watch the entire video about the service invocation building block. So the thing about that building block is that it allows you to do precisely this, and it allows you to use different name resolution technologies. In this particular case, I'm using MDNS, since I'm running in Windows and I don't need to configure anything else. However, you can also use some other technologies, for example, I don't know, HashiCorp console, right? Or others. Um, I think console is a very popular option when you have, you know, hundreds of different microservices and you need to have scalability for the name resolution processes in your solutions. So perfect, perfect. And you can also have resiliency. This is not only for the service invocation building block, but also for the state management and bindings and some others. And this is a file that you can specify. And this is a YAML file, similar to the ones that we use in Kubernetes and for other components. And this is actually the contents of that resiliency YAML file that you can specify. For example, you can see that I have API version kind. The kind is resiliency, metadata, and you have to specify the scopes and the kind of policies that you want to pose for this resiliency policy. I'm sorry, for this resiliency document. For instance, timeouts, retries, circuit breakers, and so on. And let me show you one example, right? So you specify this file and implement it inside a folder when you're developing your solution, or of course you can apply it in your Kubernetes cluster, just like any other object, right? Remember, resiliency is not only for service invocation, but also for state management and bindings. And I strongly recommend you go back to the other sessions where I was using that resiliency.yaml file for showing that capability. So state management. State management is another building block. Again, you can go back in time and watch the recordings here in CSharp TV. And state management is quite useful for storing state, right? Hence the name. But of course, don't be confused about the state management building block, since it's not an ORM. Okay, this is not a replacement for your regular database, right? This is for storing state. Sometimes that state could be just a key value pair, or maybe it could be a quite complicated structure or document. However, this is not a relational database. This is not a replacement for an ORM or so on. Okay? So again, you use the Dapr sidecar and you save the state and you somehow use it for your purposes. And nowadays we have a lot of different components for state management. And you can see in this particular screenshot, I'm displaying the ones related to Microsoft Azure, right? But of course, there are some others. And let's go ahead and let's go back here. So let's use this other branch, which is state end. So in this other case, let me show you what I did, okay? Let's open up patient controller. So far, so good. Nothing changed, right? I'm using publish event. This is the pops up building block. Let's go and open the consultations controller class. And let's see what's going on here. And right here, line 80, as you can see here, in the method that is being invoked by the / consultation ID when retrieving a particular consultation, I'm storing the state for that particular consultation instead of, just going every single time to the, well, actually, I need to use some kind of if, right? Because here I'm saving the state. This is the state stored. This is the component name, and then the key, and finally the value, right? So I'm using the state store. Again, let's go back to the components folder, state store. So this is the name. This is the most important one, right? So state store, and in this case, I'm using Redis as well, since that's how it's configured when you initialize Dapr. So it's state store, and this is gonna store the state in Redis. However, just identify how beautiful this is, since I'm not using Redis itself. I'm not using the NuGet package for Redis or so on, right? I'm just using the Dapr client SDK. This is marvelous. This is fantastic. So I'm storing the state, and of course, I need some way to, validate if the state is right there, right? I can use get state, for example, or try save state. This is another one that I could use instead of just using save state. Anyway, I can go ahead and query the state and verify if that particular key exists already. And if that's the case, I can retrieve the object instead of using the service to service invocation building block. So you can see that this is some kind of cache, right? That you can use for your solutions. So let's go ahead and let's see what's going on here. Let's stop the current application. Let's run this, right? Before I do this, let me show you if I have another folder. No, this is not the branch where I have other folders. Anyway, let's go back to patients, Dapr on patients, and Dapr on consultations. And remember, friends, you can also use Dapr dashboard, right, for inspecting your current Dapr applications. By default, this is running on port 8080, and you can see that both patients and consultations are running right now in this machine, right? So you can go ahead and navigate to a particular application and understand all the different parameters and flags and information related to that application, right? Pretty cool. Okay, so let's go back here. This is running, okay? Both applications are running. And now let's try to do the same. Remember that I'm using the memory provider. That's why I need to create a new patient. Otherwise, I need to use, I don't know, the SQLite provider for Entity Framework Core or some other other storage, right? Other database. Anyway, let's create Steven Simon. This is a new ID, right? And then I can go ahead and query all the different patients. So far, so good. Now let's return to the consultations microservice, execute this. This is returning the patients, nothing fancy, since the message was asynchronously sent between patients and consultations, right? And then let's go ahead and let's clear the response just to understand what's going on here. So I'm starting this consultation between Steven Simon and Dr. ID number 1, and this is returning a consultation ID, which is number 1 as well. And I can go ahead and do this. However, in this particular case, the state was stored in Redis. How can I know that? Let's open up the terminal, Redis Commander. This is a useful tool for inspecting your Redis components, right? So here's the consultation -1, and this is the entire object that I stored, right? Pretty easy stuff. And of course, I could, add a new if statement and verify if the key exists. And if that's the case, I can retrieve the object and deserialize it, and so on, right? So the key thing here is that with one single line of code, we are storing the state quite beautifully, right? No NuGet packages, no external dependencies, just the Dapr sidecar, which is wonderful. Okay, so now, so far so good. State is fantastic. Let's go back to the PowerPoint. Remember that this is the learning checkpoint. And with the state management, you can use a lot of different state stores. In this case, I'm just using Redis, right? And you have two different consistency options. And the first one is the strong consistency, and the other one is the eventual consistency. However, if you're building distributed applications, I completely recommend you embrace eventual consistency, right? Because you have different components, you have dozens of different components running in different nodes in clusters. So it's having strong consistency is it could impact negatively your scalability. That's why you have to embrace eventual consistency, and you have to have the mindset for eventual consistency. And sometimes that's the most difficult part when creating distributed applications. The mindset of knowing that you don't have all the tables for your queries, right? You don't have the table right there for using, for executing left join or inner join or whatnot, right? You don't have that. You have to embrace eventual consistency. Marvelous. So yeah, I strongly suggest you go back in time and watch the recording of the state management building block. Okay. And you can also implement the transactional outbox pattern. And this is quite useful for microservices applications because sometimes you need to save the state of a particular object, let's say the patient, right? And at the same time, and in a single transaction, you want to send the message to a message broker instead of implementing two different processes, isolated processes, right? This is for consistency options and for consistency's sake, right? And the transactional outbox pattern can help you with that consistency, since it allows you to save the state and publish the message in a single transaction. Okay, this is for notifying the other component or application that something happened. So you have to enable transactional outbox inside your component. And I have some examples here. And again, I strongly suggest you go back in time and watch the recording of the state management building block. Sabna is asking from where I can get recorded sessions. So that's a great question. So recorded sessions are that's my man. That's my man, Stephen Simon, showing you the YouTube channel for C Sharp TV. In that channel, you can watch all the recordings for this Dapr in Action show. And of course, there are some other fantastic shows that CSharpCorner has in that YouTube channel as well. Cool. Now, bindings. If you are an Azure Functions developer, bindings can be quite familiar to you, since bindings are objects that allow you to trigger your application with some data and communicate to other components or external applications with that particular data or some other data, right? So this is just a way for creating event-driven applications, since an event is triggering your application somehow or microservice, and then your code is reacting, your code is running, and you can go ahead and interface your application with other external systems. And this is actually what's happening in Azure Functions, right? If you happen to be an Azure Functions developer, this is what we do. We implement triggers and bindings, and basically that's it. So bindings, they allow you to avoid the complexities of connecting to and pulling from other systems or applications. So this is an example of a component for bindings. Again, API version, kind metadata, and spec. And you can see that inside the type that is in the spec, you specify what kind of binding you're referring to. So that's it. That is actually the slides for bindings. Let's go back to the code. And here, I'm sorry about that, bindings and, okay? Bindings and what happened in this other branch. Let me show you. Let's go back here and stop this and also this, right? So far, so good. Now, let me show you what's going on here. Patients controller. This is the place where we register patients. And in this case, I think everything is the same. I'm just publishing the event, right? Everything is the same now. But if I open the consultations controller class, we can see, where is it? This is the place for the pops up component, service to service invocation, and is this the place? HTTP post start, and I believe so. So, because I created this code the other day, let me show you what's going on here. In this branch, which is bindings, and I have this other folder where I have this queues YAML file. And what's happening here is that I'm using an Azure storage queue. I'm using the storage account that I deployed in my Azure account, and I'm sending some queues or receiving queues. That's what I need to check right now. And this is the way for connecting to the storage account, specifically to the queue, to the queues capability of that Azure account. So let me show you, or let me see what's going on here, since I don't remember this particular implementation that I did the other day. So I don't believe I'm using that. Am I using that? Queues, yes. I was looking for code inside the consultations controller, but it's inside the patient's controller. So what's happening here is that I'm using this HTTP post attribute, just a regular attribute, and I'm using this name, which is queues, right? And this is the name of the component, of the binding component that I want to use. In other words, I'm receiving those messages that are inserted in the queue, right, for creating patients. This is just a way of, I refactored the code for creating patients externally as a way of showing how some systems work when you are, interoperating between platforms. Sometimes you need some kind of middleware. And in this case, I'm using the Azure Queues component, right? So let's, please bear with me. I'm opening the Azure portal in this other browser, which is in another monitor. And let me show you. It's right here, right? This is the storage account. And I have the queues named my queue. That's the name, right? Here in the queue name property that I'm using. And let's create a new message. And let's see if this is complete, because I was implementing this code the other day. So this is expecting a new patient, again, first name and last name, as a way of creating patients, right? So let's verify if everything is running correctly. I should be able to use this, and let me pass components path, since you need a way to specify where your, YAML files, your new components are implemented. Okay. So that's why I'm passing components path. Actually, that's the old name of that flag. The new one is resources path. You can use that as well. The thing here is that you're saying to the Dapr sidecar, hey, you know what? In this folder, go and check all of the different files that are inside that folder and see if you can use those. That's what's happening here. And let's change the folder to consultations. This is patients. This is consultations. Dapr ROM, blah, blah, blah. I don't think I need components path in this other application, since I'm just using the queues, that binding in the patient's microservice. So I believe I don't need that components path or resources path flag here. Let's see what's going on. Let's execute this other application. And let's return. So in this case, of course, if I clear the responses, clear response, and then execute this, of course, I don't have patients right now. Remember that I'm using the in-memory data provider, right? So if I go to the Azure portal and then create a new message, such as first name, it's going to be my name, and then last name, my last name, and then I send this message to the queue, I can go ahead and see what's going on, right? So this is supposed to receive that message. So it looks like I'm having one or more validation errors. Um, so yeah, it looks like my JSON is not very well formatted or something. Um, did it work? No, it didn't. So my message is wrong. Create message, first name, or new patient. I'm sure there's something wrong here, but I can't remember what it is. Um. Anyway, you saw that the message was received by the binding. Of course, the JSON itself is wrong. First name, last name, new patient. Should I use new patient like this? New patient and then the entire structure? Should I do this? I'm just wondering, since I don't remember having this error, and of course I need to debug this application. However, the key factor here and the main thing is that this method is going to be invoked automatically by the fact that I have a new message in the queue, right? I have some serialization problems right now. Um, and again, yeah, this is trying to retrieve this message. Invalid start of a value. The new patient field is required. Is that the error? New patient field is required. Add message, new patient. So this is I believe my JSON is formatted correctly. New patient is going to be first name and then last name. This is what this is expecting. First name, last name. Interesting. So let's see if this is the case. Is something uh, is the one that is wrong? But I don't think so. I don't think so, because serialization is ignoring the case. Yeah, the new patient field is required. This is fantastic. This is fantastic. Let me see if we can just go and do this, friends. Right? Let's receive the object and see what's going on. Right? Log information, and then let's do log information, and then receive new patient, new patient, new patient. That's fantastic. Thank you very much, IntelliCode. And yes, let's stop this. .NET Build. Oh, .NET Build, and then Dapr run with those components. New patient field is required. Yeah, somehow my JSON message is wrong. So maybe I can try using a single text, a single line of text, instead of trying to format this message as JSON. Anyway, the code is right there for you to grab and see what's going on. And let me show you, please bear with me. I'm gonna show you the repo for this solution. which is right here. Hold on, I'm using this other monitor. Um, where is it? Dapr in action. Yes, this is the one. Okay, so you can see that the code has been sitting right there since 3 weeks ago, and yeah, I'm gonna tell you what's going on in that particular message in the next session, since I won't have the time to see what's going on with that message today. Okay, cool. So initially, the learning checkpoint was a single, or was prepared for a single session. But of course, in the last session, I was choking and struggling with some health issues. And that's why we splitted the learning checkpoint in two parts. And today was part two. Remember, you can go back in time and watch all the different recordings that we have. And in the next session, we will continue implementing some other building blocks, such as the workflows building block and the actors building block, and so on. So we're right in the middle of the show, and yeah, let's call it a day. And thank you for watching. And remember, you can go back in time and watch the recordings, and you have the repo right there in GitHub. Let me show you once again the URL. I'm gonna put it right here. This is a place where I'm gonna upload all the different applications that I'm building in this show. Okay, perfect. So thank you for watching, friends, and see you next time.